Hello friends, welcome back to the bench. Our patient today is a patient from a while ago, which is a Z390 from Gigabyte, Morris Pro. Now, this is the board that we couldn't get the CPU socket soldered on correctly. Now, the main reason is after I reviewed the footage, after I retried a few more times, I concluded that the board is just not getting hot enough. That's problem number one. And problem number two, overall heat is not distributed enough. So some places get hot enough to melt the solder, but some places aren't. And the key over here is that we need to heat up the entire socket at the same time so it drops. Otherwise, it's not going to drop. Which means we need two things. First of all, a little higher temperature on the board. Number two, a nozzle. So, first modification, I removed the board holder that was creating a distance between the heating element and the board. So now the board is flush on the heating element and it is covered with aluminum foil, and we only expose where the socket is. Now, is that going to be enough heat? The heating element itself, when you set it to 400 and observe with thermal imager, the temperature is around 280 degrees. So we're showing 400, but it's nowhere close to 400. So that's the problem number one. The heating element is just not getting hot enough. The solution to that would be to remove the heating element sensor, the temperature sensor, and place it either on the board or place it a little somewhere else, basically allowing the heating element to go higher. Second option would be to just recalibrate, and that 400 that we're showing over here right now should be 280. But for now, what we're gonna do is just use the heating element as it is, just without any space between the board and the heating element. That gives us extra 15 degrees. So the board was heating up to about 110, 115. Now we're getting to about 128, something like that. So that gives us decent temperature. Typically, you should be able to do it with 120 degrees on the board. Second is our nozzle. So I gave it a lot of thought, and I've been thinking about it for the past few weeks. And I had crazy ideas of welding a little square element, then welding a little wires with screws and stuff, and being able to put it on my heating tube here, right? Something that I can just clip on over here, right? Then I was using this microscope stand to hold the iron, to hold the nozzle. And then after weeks of thinking about it, I kind of was walking around the kitchen and I noticed my wife's soda can, the big can, and it hit me like, why don't I just use that? However, the worst thing that can happen here, it is relatively stable, not too stable, but the worst thing that can happen is that first we're gonna melt this plastic, because a lot of that plastic is inside the can. There are some ventilation holes over here that I punched to kind of relieve the excessive heat. Second thing is that I used plastic zip ties, which means they are prone to just melt. Now, aluminum is a pretty good metal for distributing heat. It's not the best heat conductor, right? The copper is a better heat conductor, but why don't we use copper for heat sinks? Well, actually we do. And the core of the heat sink, of a good heat sink, is made of copper, and the outside of the heat sink is aluminum. Because copper may conduct heat better than aluminum, but aluminum is much better at releasing that heat, the dissipating the heat. So aluminum is better at cooling, but not at conducting heat. So for that reason, I believe that this might, the heat generated here might be dissipated by aluminum can enough that the zip tie will hold. Now, this plastic should be pretty much the same as this plastic, and this plastic withstands 270 degrees Celsius, which is the temperature that we need to liquefy the solder on it. So with all that, let's see if we can properly resolder the socket. Now, before we start, let me give you a quick update on day 4. Nothing. That was the update. I did get a great news from our friend in Australia, also looking for a job. He went for an interview yesterday, and he got the offer. He's still contemplating whether to take it, because it's majority of the company is consultants, so there's probably pretty often turnaround. A lot of people probably getting hired and laid off. So probably it's not the most stable job. But I told him, hey, you can just take this one and keep looking, right? And in case you don't like it, or in case they don't like you and they lay you off, you already have some head start, and you don't even have to put that company on your resume if it was just 2 months or 3 months that you worked for them. Just omit that one, because it might look a little suspicious. Like, why did you get laid off after 2 months or 3 months? That usually doesn't look good. But it depends on the profession, and depends on the, oftentimes it's just plainly not your fault that you got laid off. That's how it works. Sometimes it is. If it's performance-based layoff, then yeah, that kind of sucks even more. But that is pretty much it as far as my update. So at the moment, I got only one prospecting, one lead where I supplied my code sample, and one waitlisting. I was waitlisted on one. I don't even remember which one. And I keep applying. There's actually some rotation of the jobs. The jobs are being posted, new jobs. And one thing that I noticed is the job was posted 1 hour ago, and over 100 applicants already applied. So, and I knew that. Well, at least in the QA space. I'm not a QA, I'm a software engineer. But in the QA, when we were hiring a QA, we got 500 resumes in 1 day. By 1 day, I mean the next day when they checked, there was 500 resumes. So could be that those whole 500 were submitted after an hour after the job posting went live. So it's still jungle out there, but we'll see how it goes. Alrighty, so the machine is up to 400. The board is up to around 99, so a few more minutes and we're gonna turn on the hot air. I'm gonna set it to 270 and we'll see how hot the board is gonna get. Okay, we have 125 on the board. It's not gonna go much higher than that. So let's start with hot air. Let's start with minimum airspeed and 270 degrees. This will not be enough, but we'll see. Lower the nozzle. I will likely have to go up to 300 or maybe a little higher. Okay, so far the maximum temperature we went up to is 220, given that I have 270 set on the hot air, and we are on less than 50% of airflow, around 30-35% of airflow. So the nozzle is, the top of the nozzle is staying nice and cool. I don't think anything is melting on the soldering iron or the hot air station. I lowered the nozzle slightly now. 220 is roughly the temperature that is needed, minimum temperature, to melt the solder. But that was also the highest temperature I was able to achieve without the nozzle. So now let's increase the airflow slightly above 50%, and we have immediate feedback, temperature going up. I don't want to increase the temperature yet until I confirm that this is the maximum temperature I can achieve on the board with 270 set on it. Okay, so the board went up to 280 and the temperature is only visible when I lift the nozzle. When the nozzle is down, the temperature is showing a lot lower. But the temperature of the board went to 280, which is perfect. It should be plenty enough to solder it on. Now let's let it cool down slowly and see how we did. Alrighty, so here's the result. As you can see, not a single pin has melted. What does it tell us? Unfortunately, what it tells us, because we did see the 280 on the board, there's no leaded solder that would not melt in that temperature. So what it tells us is that this is lead-free solder. That is very unfortunate, but all we gotta do is just bring the board to about 340, which is very unfortunate because at such temperature, at 340, I expect the plastic is gonna start melting. There was no smoke coming from here, so that was kind of concerning to me. But what's the other explanation? That I'm reading the temperature wrong? The temperature set on the hot air was 295 at the very end, and I put the nozzle very close to the board. So I'm confident that there was at least 280 on the board over there. Yet, it has not melted, not even a little bit. Nothing adhered to the board. Not a single pin. I don't see any signs of melting either. So we're gonna try that again tomorrow, or maybe later today. I might retry off camera and see if I can get it much higher. But so far the nozzle is working great. There's nothing wrong with the nozzle. Nothing's melting. Everything works as expected. So at least we have a little bit of success. Now the only thing is to get the temperature right. And it turns out it needs to be high, pretty high. The other thing that I was thinking was if I just tinned the pads on the board with leaded solder. But probability of getting the same amount of solder on each pin just using iron is very slim. The chances are pretty slim. So I decided against it. So all I gotta do now is clean it, put the chip back on, and try this again. More flux, obviously, and try this again at higher temperature. So this time I'll put 340 on the soldering iron or the hot air, and we'll see. But would you expect that this is lead-free solder? I did not. It does kind of look like it, but then again, you know, the leaded solder doesn't look much different on when it's pre-bowled. Although, yeah, so the leaded, usually it's more shiny, and lead-free is less shiny. Alrighty, guys, that is kind of a failure, or I don't know, it's partial success because the nozzle worked great, but the socket is still not soldered on. However, we didn't ruin the socket, so I can reuse it now, which is good. I didn't lose 30 bucks. And I guess we'll try that tomorrow, because I have a lot of other stuff to do today. So so this will have to wait until tomorrow. And until then, we're not gonna know whether it will work or not. But we're getting very close. At least that. Alrighty, guys, thank you very much for watching. And I guess I shall see you tomorrow.